Salam dostlar, axşamınız xeyir, necəsiz? Bugün biz deməli 52-ci gündən bir yerdəyik. Bir neçə gün idi, yayın aça bilmirdim. Hətta 5 gün falan idi. Biraz xəstələnmişdim. Hələ də tam düzəlməmişim, səsimdə biraz qəribəlik var. İndi daha yaxşıyam. Ki, normal danışa bilirəm. Ona görə yayın açdıq. Necəsiz? Bugün gördüm ki, Tək Az adlı səhifə deməli kanal haqqında video, daha doğrusu yazı paylaşıb. Yazın görəndə çox sevindim. Qrup yoldaşım göndərdi ki, belə bir yazı paylaşıblar. Məşhur olmuşsan. Belə. İnsanların diqqətini çəkdiyini bilmək çox xoş oldu. Bir dənə yoxlayaq görək. Yayın səs falan hər şey qaydasındadırmı? Ondan sonra davam edək. Test 1, 1, 2. Test. Test. Əla. Səs də qaydasındadır. Şu an davam edirik. Deməli, axırıncı dəfə qalmışdıq hansı mövzuda? Axırıncı dəfə biz sistem dizaynla bağlı sual var idi. Onu işləmişdik. Cavablandırmışdıq. İndi elə həmin hissələrdən davam edəcəyik. Ekran falan deməli hər şey görünür. Əla. Yəni oradan qaldığımız yerlərdən davam edəcəyik. Konkurensiya mövzusunu bağladıq. Hər şey görünür. Buralarda deməli bir-birinin mövzuları izləməliydik. Okay, let's see. Necə? Bir də şort lazımdır. Bu rəngi niyə belədir? Baxaq. Deməli, timeline'ımız azdır deyək. Load balancer, system design, interview, question, solution, additional. How system design approach. How to approach system design, interview, question, real world example, company, engineering, blocks. Okay, gel devam edeyim. Ay, bu nədir? User and datagram protocol. Create high-level design. UDP necə işləyir? Yəqin o connection falan qurur, onu izah edir. High-level design. Search API, user graph service, lookup service, person service. Deməli, provided uncaped flashback disk, use spaced repetition to help you retain key system design concepts. System design deck, experience exercise deck, and object-oriented design exercise deck. Okay. heap is completed binary tree ve each node is smaller than its children. Numunelerim gösterir. Learn from the community. Feel free to submit pull request. Okay, bu heç. Bunu bir daha təzə səhifədə açıq, yaxşı görək. Deyir, client, DNS, CDN bunları öyrən. Load balancer, dastordu web server, search API. Okay. Bir gedək. Bu nədir? System design create. Okay. Buradan başlayaq. Salam Fərid. Fərid design yazdım ki, salam. Okay. Buradan başlayaq demək. System design topics start here. New to system design, first you will need a basic understanding of common principles, learning about what they are and how they are used and their pros and cons. Review scalability, video and lecture. Scalability, okay. Vertical scaling, horizontal scaling, caching, load balancing, data replication, data partitioning. Əslində mən bunların hamısı haqqında az bilirəm, amma videoya baxmaqdan bizə ziyan gəlməz. İkinci stepdə nə deyir? Scalability. Topic covers clones, database, cache, asynchronizm. Okay, buna baxa bilərik. Axşamı xeyrəli, çox sağ ol. Okay, buna baxa bilərik. Videoya da baxa bilərik. Baxaq. 1 saat 45 dəqiqə. Okay, bunu save edeyim. Mən buna sonra baxaram. İndi nəysə oxusaq yaxşıdır. Bu arada kap teoreminə baxa bilərsən başlanğıc olaraq. Çalış deyil, başa düş onu. Tamam. Coding edirsiniz canlı yayında Netcode məsələn. Netcode yayınlarını bundan əvvəlki yayınlarda edirdik, amma artıq daha çox teoretikal mövzular üzərində fokuslanmışıq. Distributed sistemlərin olmazsa olmaz teoremlər. Tamam. Okay, onda bunu yaxşı başa düşək. Consistency, atomicity, partition, tolerance. Deməli bunun adı nə idi? Acid prinsiplər var idi database-də. Orada da bu availability-dir. Səhv oxumuşam. Salam. Asset properties. Okay, buna baxaq, bunlardan başlayarıq. Yox, o topic deyil. Sonra yadıma düşdü ki, başqa. Deməli, provide at most two of the following three guarantees: consistency, availability and precision tolerance. Bir-iki dən yoxdur. Prosto baxaq da, yəni bir digəri də mediumdur. Yəni mediumdan kimsə yazdığını oxumaqdansa. O qədər artikl yazırlar. Bu videolar, yayınlar iş tapana qədər davam edəcək. Ondan sonra da başqa mövzuda nəsə tapıb bir şey davam edərik. Burada məsələn çox çirkin yazılıb. Baxaq mediumdan bari. Okay. Balancing consistency, availability and partitioning. Distributed system data need to be stored and accessed across multiple servers or nodes, ensuring the system's reliability, performance, consistency. Birdən oxusam ChatGPT kimi cavab verərəm. 3 kimi. Düzdür. Okay, onda mediumdan davam edək. Which has become a fundamental concept in design and operation of çox sağ olun distributed system. In this blog, we will delve into the CAP theorem, exploring consistency, availability, partition tolerance. In theorem, the theorem articulates inherent trade-offs that exist when designing distributed system. Okay. Statement of CAP theorem. It's not possible to guarantee all three of the desirable properties: consistency, availability, and partition tolerance at the same time in distributed system with data replication. To understand it better, let's understand. Okay, consistency. All nodes or replicas in the system have the same data at the same time. When client reads data, it receives the most recent write or an error. In other words, there is no divergence in the data observed by different nodes. Suppose we are working on distributed system having client node and two database nodes, says D1 and D2. Now let's say we have generated an update request to D1 at the same time. Okay, so generated read request at D2. So here, due to replication of the data between D1 and D2, we are able to access latest data. This is called consistency. Okay, baxır client update buraya göndərilib, replika buraya yazdı, read-də 5 oxudu. Availability refers to system's ability to respond to client requests even in the presence of node failure or network partition. An available system ensures that every request deməli, bir problemlə qeyd edə istəyirsənsə, baxırsan, two general problems, okay? How qeyd edeyim onu? Two general problems. Okay. Availability refers to system's ability to respond to client requests, even in the presence of node failure or network partitions. An available system ensures that every request eventually receives a response, though it doesn't guarantee that the response contains the most recent data. In short, availability ensures that the system is şirniyyat resepti. İnşallah başka şeyler görünmedi. Okay. Partition tolerance deals with the system's ability to continue functioning even when the network partition occurs. Network partition can cause nodes to lose contact with one another, making communication and synchronization difficult. Let's consider above example to understand it better. Suppose somehow the connection between D1 and D2 breaks down. Now the replication of data will not occur, hence consistency is not maintained. But still both systems are generating output. Okay. consistency is done, but both systems are generating output. This is partition tolerance. So even after connection breaks down, the output is being generated by system is partition tolerance. Partition tolerance. Okay. Cup theorem says that we cannot have all three properties at the same time. We can have at most two at once. So let's understand. All possible combination of consistency, availability, and partition tolerance are consistency, availability. Availability, partition tolerance, and consistency, partition tolerance. Okay, baxaq. Consistency və availability. Consistency nə idi? Bu replikasını yaradır. Aha, o hissəsini başa düşdüm. Bəs niyə belədir? Əsas bunu başa düşdüm. Tamam. Okay, onu başa düşək. Bu replika edir. Availability-də bu availability-də nə idi? Presence of node failure or network partitions. Availability-nin partition tolerance-dan fərqi nədir? Partition tolerance deyir ki, network partition can cause node to lose contact. Partition tolerance-da ilki partition arasındakı deməli connection itir. Availability-də amma request göndərəndə network-də yaranan partition deyir. Node failure. Eyni şeydir. Bu fail olur. Bir də var bu ikisinin arasındakı connection fail olur. Okay, başa düşdüm. Bu fail olanda bunun cavab verməyi olur availability. Arasındakı bu connection fail olanda bunun da cavab verməyi olur partition tolerance. Instance'ın ayaqda olması sorulara cavab verə bilməsidir. Consistent and is always available. If we break the connection between system in order to make it partition tolerant, we will lose consistency of the system. Partition tolerant eləsək consistency itəcək. Çünki buradakı data buraya yazılmır. Availability də həmişə var. Partition tolerance bir neçə instance run edə bilərsənmi? Əgər bir neçə instance'ın varsa sistemində partition toleransı tətbiq etmisən deməkdir. Bir neçə instance'ın olması partition toleransı tətbiq etməkdir. Okay. Partition tolerance etmisənsə ya available seçirsən ya da ki consistency. System's ability to continue functioning even with network partitions occur. A və B iki nodun var. If we break the connection system in order to make partition tolerant, we will lose consistency of system. Deməli, sistemdə kapın pin var. Burada deməli deyir ki, partition tolerance deal with system's ability to continue functioning even when the connection partitions occur. Əgər bu iki node arasında network issue yaransa, replication dayansa, burada consistency gedir. partition tolerance və var. Availability-ni də təmin etmək mümkündür. Connection between D1 ya consistency üstünlük verirsən, amma nodların available olmayacaq kənardan. Consistency üstünlük verirsən, ikisi bir-birindən deməli replication elədiyi üçün ikisi də məşğuldur, available deyirlər. Çünki sən istəyirsən ki, B-dən select edilən data A ilə eyni olsun, consistent olsun. Əgər consistent deyilsə, istifadəçi bu nodu sorğu ata bilməsin. Çünki sən istifadəçinin real datanı deməli görməsini istəyirsən, amma bəlkə də o artıq A-dan silib, sadəcə B-nin bundan xəbəri yoxdur. Deməli əgər konsistent deyilsə, istifadəçi bu noda sorğu ata bilməsin. Okey. Çünki sən istifadəçinin real datanı görməsini istəyirsən, amma bəlkə də o artıq A-dan silinib, sadəcə B-nin bundan xəbəri yoxdur. Bu, consistency və partition tolerance var deməkdir. Mən bunu bir də başa düşün, bir dənə. Əgər bir neçə instansın varsa, sistemi partition tolerance tətbiq etmirsən deməkdir. Partition tolerance etmirsənsə, ya availability-ni seçirsən, ya consistency. 2 dənə nod var, bunun arasında replication gedir. Deməli, sistemdə partition tolerance var. Əgər 2 nod arasında network issue yaransa, replication dayansa, ya consistency üstünlük verir, ya da nodların available olmayacaq kənardan. Consistency üstünlük verir də available olmur. Çünki sən istəyirsən ki, B-də select edin, A-da olsun. Okey. İkinci variant deyə bilərsən ki, 2 noddakı datalar real olmaya bilər. Replication dayanıb deyə. Amma yenə istifadəçi bu nodu sorğu ata bilsin. Bu halda availability partition tolerance olur. Tamam. Ama consistency pozulur. Availability partition. After breaking the connection between D1 and D2, our system becomes partition tolerant and is always available, but consistency is not maintained. Okay, çünki bunlar arasındakı qırıldığı üçün consistency getdi, amma həmişə available-dır. Yəni nəzəri olaraq bir sistemdə 3-ü 100% təmin etmək mümkün deyil. Aha. Above consistent and partition tolerance, we have to down the system in order to establish the connection between. Again, this will make our system unavailable for a while, and after connection has been established, system will not be partition tolerant. Medium'un dediğine göre bu ikisi arasındaki connection varsa bu partition tolerant değil. Ama bunlar arasındaki connection qırılsa bunun partition tolerantdır. Səhv mi başa düşürəm mən? Burada da deyir ki partition tolerance deal with system ability to continue functioning even when the network partition occur. Distributed systems ability to continue operating when the network partition occur. Əgər bir neçə partın varsa, partition tolerance var deməkdir. Network issue zaten temporary yaşanır, sonra bərpa edilməlidir təbii ki. We have done the system for necessary repairs. Okay. DynamoDB is designed to provide high availability and partition tolerance. It replicates data across multiple availability zones to ensure data durability and availability. During network partitions, it might not provide strong consistency by default. Google Spanner database is an example of SP system. It achieves strong consistency but by using synchronized clock and a globally distributed architecture. However, this comes at the cost of potential unavailability in the event of network partitions. SA necə olurdu? Buna bir dənə baxaq. Evet. Deməli, consistent always available. If we break the connection between system in order to make partition tolerant, we will lose consistency of system. Deməli, ancaq məsələ burasındadır ki, əgər issue varsa və replication dayanıbsa, sənin geridə qalan sistemin available olsun, yoxsa load balancerdan çıxarıb gözləyirsən ki, replication bərpa edilsin və data consistent olsun. Single instance sistemlər buna aiddir. Okay. Başa düşdüm. Consistent olanda available olmur. Amma consistent və available olursa single instance sistemlərdir. Single instance sistemi nədir? Yəni partlar yoxdur, yalnız bir noddur. Okay. Onda başa düşdüm. Burada yoxdur partlar. Burada 2 dənə var axı. D1, D2, do you want it to? Onda necə consistency-nin nə mənası var? Nələrin arasında consistent edəcək? Partition tolerance bir neçə nod olanda sistemlərə aiddir axı. Every reader receives most recent write. Every request receives a non-error response. The system continues to operate despite network partitions. Some nodes can talk to each other. Sen bir database'de transaction'ı atomik execute edebilirsin. Single node system strongly connected clusters. Aha. Eğer hiçbir network partition yoksa. CA var. You write some data to database. You read data from same database immediately. Since there is only one node, it always most recent value. Okay. Bir tane node olduğu için consistent'tir. Database həmişə cavab verir, available-dır. Bir neçə node olanda replication məsələsi ortaya çıxır. Hə, çox sağ ol. Bunu başa düşməyə çalışacağım. Əslində başa düşdüm. Sadəcə bir-iki dənə suallarım var. Onları indi araşdırım. Bir neçə resursdan baxsan əla olar. Tamam. Əslində az çox başa düşdüm. Suallarımın cavab tapım yəqin aydın olar mənim üçün. Başa düş, sonraki yayınlarda bir də üstündən keçərik bu mövzunu. Tamam. Çox sağ ol. Mən də sizdən ilham alıb bəlkə iş tapana kimi cyberlə əlaqəli yayınlar açım. Məncə açın. Kod yazmaq maraqlıdır. Videoların olmağı da yaxşıdır. Digər insanlar da yararlanır. Düzgün başa düşməmisən, çünki bir bütöv anlayışda tam dəqiq başa düşür. Anlayışda tam dəqiq başa düşürsən, başa düşəndə. Çox sağ ol. Hə, düz tam dəqiq başa düşməmişəm. Consistency və availability başa düşüm ki, single node sistemlərdə olur. Single node olduğu üçün həmişə consistentdir, bir yerdən oxuyur və həmişə available-dır əgər network partition yoxdursa. Okay, bunu başa düşdüm. Okay, bunu başa düşdük. Deməli, burada consistency var, partition tolerance var, availability yoxdur. Nədir? All nodes agree on a single up-to-date state, consistent state. System continues working even if there is a network partition. But during a partition, if consistency cannot be guaranteed, system nodes will reject request. Aha. Consistency-ni təmin etmək üçün bəzi requestlərə cavab vermir. During partition, if there's a network partition, system continues working. Eğer consistent değilse reject the request. You have two nodes, node A, node B, network var aralarında. You write a value to node A. Now the network goes down partition. If user tries to write to node B, system block or reject the write because it cannot guarantee the same state on both nodes. When the partition heals, everything is still consistent. You always read latest correct data. Okay. İki nod var. İki tane nodun arasında network var. Eğer network partition baş verirsə, iki nod da işləyir. Partition tolerance. Əgər deməli təzə bir request gəlirsə, məsələn A noduna, ikisi də eyni state'də olmadığı üçün həmin request'i reject edir. Bu halda availability yoxdur və artıq state'i bərpa olunandan sonra, consistency bərpa olunandan sonra heç nə request'i qəbul edir. Availability partition tolerance. Deməli, system remains available even when the request network partition occurs. Okay. Network partition baş verəndə hər ikisi işləyir. İkisi arasında əlaqə qurulur, hər ikisi işləyir, hər ikisi gələn requestə cavab verir, amma ikisi də fərqli state'dədir. Consistent deyil. Possible still answer than no answer at all. Okay. Node A, node B. Write to node A is successful. Write to node B also successful. But they now have different data version. When the network heals, system can runs conflict resolution or merging. Last write wins. Vector clock. To restore consistency eventually. Always response. Many temporary return state, stale or conflicting data. Okay. Okay. Capture introduced by Eric. Okay. Provides fundamental network fundamental framework for understanding the trade-offs that must be made when designing a distributed system. Okay. Consistency, availability, partition tolerance. Stands for bunlar bildi. It's impossible for distributed data to store to simultaneously provide all three guarantees. Okay. Deməli, consistency ensure that every read receives the most recent write or an error. This means all working nodes in distributed system will return the same data at any given time. X error. Çünki bunun dəyəri məsələn fərqlidir. Deməli, bura kopyalanmayıb. In a consistent distributed system, if you write data to node A read operation from node B will immediately reflect the write operation on node B. Node A. Okay. Consistency is circular for application where having the most up-to-date data is critical, such as financial system where balance inquiry must reflect the most up-to-date state of an account. Okay. Availability guarantees that every request receives a response without ensuring that it contains the most recent write. This means that system remains operational and responsive even if response from one node don't reflect most up-to-date data. Okay. Farklı olabilir, hamısı cevap verir. Availability is important for applications that need to remain operational for all times, such as online retail system. Partition tolerance means that system continues to function despite network partition. Okay, anladım. P'nin olmadığı nedir? Availability ve consistency'dir. Hansı ki single node sistemdə başa düşür. Okay, ona göre anladım. Part olanda partition tolerance olur. Okay. Okay, başa düşdüm. Partition tolerance olanda onsuz da network partition baş verə bilər. Əsas olan onu çox çəkmədən düzəlməsə də. Okay. Network partition occur when network failure causes a distributed system to split into two or more groups of nodes that cannot communicate with each other. When there is a network partition, system must choose between consistency and availability. Yani ya consistent ve partition tolerant olmalıdır ya da available olmalıdır. Available olsa ikisinin arasındaki bu connection kırıldığı için bunlar ne yapabilmeyecek? Replication getmeyecek. Ona göre her biri farklı cevaplar return edecek. Available olsa bu olur. Consistent olsa cevap vermeyecek. Bu network error gönderecek. Bu request'e cevap göndermeyecek response ve replication bu ikisinin arasında network failure düzələndən sonra bərpa olmağa çalışacaq. Burada deməli nə deməli? Əgər issue varsa və replication dayanıbsa, sənin geridə qalan sistemin available olsun, yoxsa load balancerdan çıxarıb gözləsin ki, replication bərpa edilsin və data consistent olsun. Okay, başa düşdüm. Okay. Partition tolerance is essential for distributed system because network failure can and do happen. A system that tolerate partitions can maintain operation across different network segments. Okay, the cap trade-off choosing 2 out of 3. In the presence of network partition, a distributed system must choose between consistency and availability. System prioritize consistency and can tolerate network partitions, but at the cost of availability. During a partition, system may reject some requests to maintain consistency. Traditional relational database such as MySQL and PostgreSQL, when configured for strong consistency, prioritize consistency over availability during network partitions. Banking system typically prioritize consistency over availability since data accuracy is more critical than availability during network issue. Consider an ATM network for a bank. When you withdraw money, system must ensure that your balance is updated accurately across all nodes. Consistency to prevent overdraft or other errors. Okay, bu oldu consistency ve partition tolerance. Okay, the system ensures availability and partition tolerance. System ensures availability and can tolerate network partitions, but at the cost of consistency. During partition, different nodes may return different values for the same data. NoSQL database like Cassandra and DynamoDB, designed to highly available and partition tolerant potentially at the cost of strong consistency. Okay. Amazon's shopping cart system is designed to always accept items, prioritizing availability. When you add item to your Amazon cart, action almost never fails, even during high traffic period like Black Friday. Okay. Available'dı ve partition tolerant'tı. Ama consistent değil. In the absence of partitions, yani eğer iki part yoktu, bir tane single system'sa, system can be both consistent and available. However, network partitions are inevitable in distributed system, making this combination impractical. Single node database can provide both consistency and availability, but aren't partition tolerant. In distributed setting, this combination is theoretically impossible. Okay. If I have a single node database, how this is distributed system? How is this distributed system? Okay. If you have only one node, there is no network partition to tolerate. So technically, a single node database is not a distributed system. By either shutting down the nodes during partition or specifying. How can a distributed system be consistent and available? Because I would argue that when a network partition occurs, it cannot be possible in a way where every node of the network even partitioned nodes that user are connected to continue to be available and answer with consistent data. It can't. As often mentioned, CAP theorem in its original form is a little misleading. It can be restated as, in presence of network partition, a distributed system is either available or consistent. So you are right, generally a system cannot be specified as, since partition tolerance is property of system which describes what to choose in case of a network partition. Possible that system can behave according to AP sometimes or an SP other times. Another interesting part is that RDBMS databases are often at the SA side of the triangle. This is only the case in single node setup, even with master writes slave read setup. The system is not SA, or it's termed or if it is termed SA for some reason and cannot recover from network partition, then split brain scenario may happen. New master is selected for partition and cause ensures possible breaking system consistency of the system. Okay. Bu split brain senaryonu ben eşitmiştim. Demek bir tane master olur, bir tane slave olur. Master sadece write'ları qəbul edir, slave ise sadece read operationları. Eğer bu ikisi arasındaki deməli əlaqə olmasa, network partition baş versə, bu halda slave deyir ki, master işləmir, ona cavab gəlmir, mən onda masteram. Başlayır read operation, write operationları da qəbul eləməyə, bütün hamısını. Master da deyir ki, aha, slave işləmir. O da başlayır read, write hər ikisini qəbul eləməyə. Burada deyir split brain scenario. Yəni yadımda elə qalmışdı. Amma bunun ilə nə əlaqəsi var, onu anlamadım. At the SA side of the triangle, this is only the case in single node setup. Even with master write, slave read setup, the system is not SA. Hə, çünki 2 dənə part var da. Hə. Okay. Hə, yəni məntiq nədir? Okay. Single node database can provide both consistency available and partition tolerance. Distributed this combination is theoretically impossible. Distributed system olup həm də ki partition tolerance yoxdur. Mümkün deyil. Yoxsa mümkündür. Çok qəribə cümlə olsun. If you try to build a distributed system with multiple nodes, network partition will eventually happen. If you want to stay consistent, you need to coordinate between nodes. If a partition happens and node can't coordinate, you must reject some requests not available. If you want availability, node must serve requests even during partition, but then you may diverge. So not consistent. That's why CA is realistic for single node non-distributed setup. Okay. Yani consistency, availability sadece single node system, non-distributed system için mümkündür. Impossible in real distributed system that must tolerate partitions. Okay. System can continue to function even if messages between nodes are delayed or lost. A network partition happens when 2 or more nodes cannot communicate due to network failure. Each partition may still be up and running locally but can't talk to each other. Cannot communicate. Router or switch failure nəsə bunlar baş verə bilər. If it's truly distributed, partition tolerance is mandatory. Fails between nodes and system cannot tolerate, the system will break. We choose and still called resilient distributed system. Ha, buraya düştük. CA theoretical. Okay. Designing distributed systems require careful balancing these trade-offs based on application requirements. Here are some practical strategies. Eventual consistency. For many systems, strict consistency isn't always necessary. Eventual consistency can provide a good balance where updates are propagated to all nodes eventually, but not immediately. A system where immediate consistency is not critical, such as DNS and Content Delivery Network, CDNs. Okay. Strong consistency. A model ensures that once a write is confirmed, any subsequent read will return that value. Okay. Example system requiring high data accuracy, like financial application, inventory management. Tunable consistency allows system to adjust their consistency level based on specific need, providing balance between strong and eventual consistency. Cassandra allow configuration the level of consistency on per query basis, providing flexibility. Needing different consistency level for different operations, such as e-commerce application where order processing requires strong consistency, but product recommendation can tolerate eventual consistency. Quorum-based approach use voting among a group of nodes to ensure certain level of consistency and fault tolerance. System needing a balance between consistency and availability often use in consensus algorithm like bu nedir? Okay. While CAP is foundational, it doesn't cover all scenarios. Daniel proposed the Parcells theorem as an extension by introducing latency and consistency as additional attributes of distributed system. Latency and consistency. If there is a partition, trade-off between availability and consistency. Okay. Else, the trade-off is between latency and consistency. Eğer partition varsa availability consistency, eğer partition yoktursa latency ve consistency arasında. This theorem acknowledges that even when the system is running normally, there is a trade-off between latency and consistency. CAP theorem is a powerful tool for understanding inherent trade-off distributed system design. It's not about choosing the best property. Okay, bunlar belli. Aha. Yok, boşa düştü. Okay. Prosper, acceptors, learner. Key concept. Okay. A fault-tolerant consensus protocol that allows a group of unreliable processors to agree on single value. It works by using three roles: prosper, acceptor, and learner, to reach an agreement. Even in event of network failure or node outage, core idea is that a value is chosen once a majority of acceptors have agreed upon it. Desem bunu da desem mən yadımdaydı. Necə idi? 3 dənə nod var. 3 dənə nod var. İkisi arasında consistency var. Üçüncü arasında consistency yoxdur. Üçüncü arasında consistency yoxdur. Gəlir oxuyur birindən, məsələn A nodundan. Yo. Gəlir A noduna yazmaq istəyir. Soruşur ki, sənin dəyərin nədir? Görür indi ki, bunun dəyəri x-dir. Baxır, görsün B nodunda dəyər nədir? Görür onda y-dır. Aha. S-də də məsələn ay yox, nəsə budur, bu başqa idi deyəsən. Mən onu hardan baxmışdım? Bu değildi. Deyəsən buydu.
So the problem is not actually
Deyəsən bu değildi. Neyse. Buna baxaq. Deməli, consensus, deməli, prosper, acceptor, and learner. Goal is for distributed system to agree on single values such as database state or transaction order despite potential failure. Fault tolerance algorithm can continue to function even if some nodes or network links fail. Each node in system can play one or more of these roles. Prosper, create, proposer. Mən niyə bunları səhv oxuyuram? Heç belə bir şey yoxdur. Proposer, acceptor, learner. Okay. Proposer. Create proposal with unique proposal number and submit them to acceptors. Neredeydi? Create proposal with unique proposal number and submit them to acceptors. Acceptor vote on proposal and acceptor promise not to accept old proposal and accept new proposal if they met certain criteria. Okay. Buna baxaq.
Okay. Now Paxos algorithm is trying to get the consensus. So it has multiple rules, like different nodes will behave differently based on the data. So it has 3 rules available. So one is proposer, second is acceptor, and number 3rd is learner. Okay, proposer is the one who proposes an idea or proposes to prepare for a plan and proposes to accept an idea. That is a leader. Okay, so that's the proposer. Once proposer's idea is accepted, it will be a leader. Acceptor is someone accepting that request and accepting the value the proposer is asking for. And learner is the one who learns the idea, like, okay, what's the idea that was agreed upon and what's the consensus. Okay, now different nodes are available within your cluster, and any of the node can be any of the roles. Okay, so suppose node 1 can be a proposer as well acceptor as well and learner as well. And node 2 can be just an acceptor. And later in node 2, if he wants to be a proposer, node 2 can be a proposer as well. Node 2 can be a learner as well. So that means that any node can have any number of roles. It is not like that one node can have only one role. Okay, one node can have all the roles as well. So that's the idea behind the different roles and how the roles are defined and what is the actual purpose of the role. So proposer will propose the idea, acceptor will accept those ideas, the learner will learn about those ideas to understand what was the consensus received across all the different nodes. Great. Now, as we understood about the two phases of the Paxos algorithm and the different roles, let's understand how the Paxos algorithm works. Let's consider multiple servers. So let's consider server 1, server 2, server 3. Okay, so here you can see that I have 3 different servers available, 3 different nodes available in my database application system. Now, let me say that this one is my proposer. Okay, S1 has taken the proposer role, S2 has taken the acceptor role, S3 has also taken the acceptor role. Great. Now, out of these 3 nodes, everyone wants to be a leader. As S1 say that, okay, I want to be a proposer, let me propose an idea to be a leader. So S1 will start the phase 1, that is the prepare phase. Okay, so S1 will start the prepare phase. So what it will do is it will prepare a request. So it will prepare a request that, okay, prepare yourself to S2, prepare yourself to S3. So it is sending request to all the different nodes. Now, when this request has been sent, 2 things needs to be created. Okay, first thing is that it has to have the ID, that is the identifier of that particular request. And whatever the ID has been sent in this request has to be the greatest value. Okay, greatest value that this proposer, this node has seen. Okay, so suppose there are 4 values that already been seen within this node servers, then S1 should send value 5. Okay, the second thing is it should be unique across the server. So across all the distributed nodes, the value which has been selected to send to all the different servers to prepare for the messages, it has to be unique. Okay, so server 1 and server 2 both cannot send the 5 value. Okay, it has to be unique. So now with these 2 categories, we have identified that, okay, I am sending value 5 to server 2 and server 3. Great. So I'm sending server 2 as prepare for 5, server 3 as prepare for 5. Great. Now, server 2 received the message, server 3 received the message, and both identified this thing that, okay, whatever value that got, which is 5, is greater than the maximum value that I've seen, n. Okay. So they have not seen any value greater than 5 till now. If that's the case, then they will send a promise message. Else, they will send a NAC message that it's a negative acknowledgement. We have seen a bigger value than this. We are not promising you the data. Great. So if server 2 and server 3 has seen the latest value is 5, they are promising it. Here, they have not seen any value greater than 5. Server 2 saw that 5 value is the greatest. Server 3 also saw that 5 value is the greatest. So both will promise the message. So let's understand that. Okay. So now server 2 send the promise message. Okay, I'm promising. Server 3 also send the promise message. Great. So now server 1 got the data that, okay, server 2 and server 3 promised for value 5. So this is the phase 1. That is the prepare phase. Great. Phase 1 is completed. Now phase 2, that is the accept phase. So now once server 1 received both the acknowledgements, both the promise from all the servers, okay, and this time also it has to get the maximum promises out of all the nodes available. If server 2 and server 3, out of those 2, if only one server 2 is sending the promise and server 3 is not sending, then server 1 and server 2 both have sent the promise. Server 1 will also send the promise message to itself, because server 1 can also be an acceptor. As we
Anlamadım. Kalsın. Neyse, aslında biz başa düştük. Başa düştük. Bu yaxşı idi. Bu deməli sistem dizayn. Yəni okay. Aktardığımız şeylere bakarak onu burada. Scalability. Okay, scalability'ye baxaq. Nədir? Okay. Bunu oxuyarıq. Hələ ki lazım olanları qalsın. Okay. Neyse, I'm sorry. Okay, content delivery network is geographically distributed group of servers that cache content close to end user. Content delivery network allow for quick transfer of assets needed for loading internet content, including HTML page, MacBook modelini M3 Pro. Transfer of assets needed for loading network content, including HTML page, JavaScript files, style sheet, images, and videos. Popularity of CDN services continues to grow, and today, çok sağ olun. And today, majority of network web traffic is served through CDNs, including traffic from major sites like Facebook, Netflix, and Amazon. Properly configured CDN may also help protect website again. Okay. Host content can't replace system for proper web hosting. It does help cache content at the network edge, which improves website performance. Many websites struggle to have their performance need met by traditional hosting service, which is why they opt for CDNs. Deməli, algoritm DC üçün netcode və vizual algoya da baxa bilərsiniz. Vizual algo bunu baxmışdım bir ara. Bu konsepti başa düşmək üçün çox yaxşıdır. Netcode'dan da ora mən bir dənə ödənişlidir. Burada bunlara baxmışdım. Bir necəsinə. Burada da ikisi free'dir, qalanlar ödənişlidir. Improving website load times by distributing content closer to website visitors by using Netcode, LinkedIn ve YouTube üzerinden veya hansısa platform üzerinden ödənişsiz paylaşır, səhv etmirəmsə. Netcode, LinkedIn'də bir dənə link paylaşmışlar, hansısa harasa abunə olanda, daha doğrusu hansısa üzv olanda, hansı bilmirəm təşkilat idi, ora verirdilər. Sadəcə yox, o limitli saydaydı, 150 dənə filan idi deyəsən. Və avqustdaydı, çoxdan tükənib məncə. Okay. Distributing content closer to website visitor by using nearby CDN servers, among other optimization, visitors experience faster page loading times, as visitors are more inclined to click away from a slowdown loading site, can reduce bounce rate and increase the amount of time that people spend on website. Faster website means more visitor will stay and stick around longer. Reducing bandwidth cost, bandwidth consumptions. Reducing bandwidth consumption cost for website hosting is primary expense. May improve security by providing DDoS mitigation. A network of servers linked together with the goal of delivering content as quickly, cheaply, reliably, and securely as possible. In order to improve speed and connectivity, we'll place servers at exchange points between different nodes. The Internet Exchange Points, XPs, are the primary location where different internet providers connect in order to provide each other access to traffic origination on their different networks. By having a connection to these high-speed and highly interconnected locations, a CDN provider is able to reduce costs and transit bit times in high-speed data delivery. Okay. Əsas baza dizayn sistemləri çox yaxşı anlayıb, daha sonra tədricən kiçik addımlarla çətinlərə doğru getməyi çox məsləhət görürəm. Bilmirəm, bəlkə də proseslər keçmişsiniz, amma bazanı o səviyyədə başa düşməlisiniz. İmplement edə bilərsiniz. YouTube-da yəqin ki, izləmişsiniz müxtəlif blogları. Kimlər uğurla keçib texniki belə lokalda iş tapmaq üçün sadəcə məğzini tutmanız bəs edir. Aha. Əsas baza DS-ləri çox yaxşı anlayıb, daha yaxşı tədricən kiçik addımlar çətinə doğru getməyi çox məsləhət görürəm. Baza və dizayn sistemləri. İndi çalışıram ki, öyrənim. Çox sağ olun. Baza data struktur. Data strukturlarda əslində elə də bir çətinliyim yoxdur. Data strukturlarda çətinliyim yoxdur. Onunla bağlı videolar paylaşmışam əvvəlində problemləri həll etdiyimiz. Amma çətinliyim olan hissələrdə baxıram, öyrənməyə çalışıram. Çox sağ olun. Beyond placement of servers in the Internet Exchange Points makes a number of optimization on standard client-server data transfers. CDNs place data center at strategic locations across the globe, enhance security, and are designed to survive various types of failures and internet cognition. İşte burada bir neçə Internet Exchange Point var. Onlar sürətə qoşulub, deməli, high speed data delivery-ni təmin edir. High speed and highly interconnected locations able to reduce cost and transit time in high speed data delivery. How does CDN improve website load time? Necə deməli improve eləyir? When it comes to website loading content, user drop off quickly as site slows down. Reduce load time in following ways. Global distributed nature of CDNs means reduced distance between users and website resource. Instead of having to connect the wherever website's origin server may live, CDN let user connect geographically closer data centers. Less travel means a faster service. Hardware and software optimizations, such as efficient load balancing and solid-state hard drives, can help data reach the user faster. Reduce amount of data that transferred by reducing file size using tactics such as minification and file compression. Smaller file size means quicker load times. Also speed up sites using TLS certificates by optimizing connection reuse and enabling TLS fast start. Okay. Buralar başa düşdük. Internet phone book domain name server. Bunda necə işləyir ona baxaq. resolving namespace, name server, roots, name server, DNS records, human readable domain names, IP address. Okay. So content message retail website. Find and communicate which one with one another by using content using numbers, IP address. You don't have to remember. Okay. DNS and TCP IP. Application Transport Internet Network. Protocols. Okay. Telnet. Bunlar hansı layer'da olurdu? Transportda TCP, UDP. Okay, bunun nə dəxli var indi? Okay. DNS application transport layer'da olurdu. Okay. DNS server, DNS client service use DNS protocol that is included in the IP protocol suite. DNS is a part of application layer. Okay, DNS application layer'ın bir hissəsidir. Okay, DNS application layer'ın bir hissəsidir və TCP IP protokolun da var. Onlardan biridir. Application layer'ın bir hissəsidir. Okay. Enhance functionality and performance in Windows environment. Active Directory integration, dynamic updates, caching, monitoring, logging. Can be deployed in various scenarios with diverse organizational needs. Active Element Directory domain service is integrated to facilitate domain controller and location authentication. Okay, neyse. Başa düşdük. Application layer'da olur və nə işə yaradığını da bildik. Discover domain controllers, computer name to IP address. Mən əslində bunu ardıcılığın tam olaraq necə baş verir, hamısını yazmışdım. Ama olsun. Tamam, görünce taparım. Hemen test generator. This is one of the core networking concepts that feel magical. The Mənə doesn't. Okay. Check local cache. Okay. Birinci local cache'i yoxlayır. Daha sonra nə iner? Step 1, check local cache operating system browser. Browser and operating system. Okay. Keep small DNS cache. If IP is already stored because you visited recently, it returned immediately. If not found, system sends DNS request to next layer. Okay. Your browser might have cache from previous visits, so it never ever goes to network. Never even goes to network. Ask a recursive resolver, DNS resolver, usually provided by your ICP or public DNS like Google public DNS or Cloudflare. Your device sent a query like what is IP of example.com. If resolver already cached the result, it immediately replies immediately. Otherwise, it starts a recursive resolution. It goes out and finds answer for you. Okay. Root name server doesn't know the IP. Root name server only certain logical root name server cluster. Root server but they are mirrored globally. The root server doesn't know IP of, okay, but it does know where TLD servers are. It responds something like, I don't know IP of, but ask the .com TLD server. TLD server doesn't know the IP either, but it knows which author this name server is responsible for example.com. Ask ns1example.com at IP. Finally, alternatives DNS server for example.com. Okay. Caching result. Browser cache, operating system local DNS cache, recursive resolver, root name server, TLD name server.com kimi mesela, authorities name server example.com, IP returned. Okay. Why extra why DNS is fast in real life? Okay. Okay, go ahead. Okay. Bu nerede? Aha. Biz indi deməli global problem buna baxdıq. Heç bir problem yoxdur. To general problems. Bunun adı nədir? Algı master ayı. Biz bu capture'ın bildiği, CD'nin bildiği. Bunlara baxaqdan. Proxy, reverse server, proxy. Bunu da bildik. Bildik də, hə. Okay. Server that sits between client and internet. Client ve internet arasında. Is opposite or it sits in front of one or more servers. Okay. Okay, başa düştü. Reverse proxy falan bunu da bilirik. Latency de HTTP bilirik. API. Okay. Vertical, horizontal load balancer. Bunu da bilirik. Vertical. Vertical partitioning bilmirəm. Caching bilirəm, denormalization, cap bildik, blob storage, CDN bildik. Okay, neyse bize two general problem lazımdı. System Baxaq. Okay. The two general problems is taught the experiment in computer science and distributed system that highlights the challenge of achieving reliable communication over an İnşallah devam edelim. Deməli, highlights challenge of achieving reliable communication over an unreliable network. Problem remains unsolved and it illustrates the inherent difficulty in coordinating action between two parties, generals in this case. But generals problem. When message can be lost or interrupted. Two generals are stationed on opposite hills and they want to coordinate an attack on a city between them, but both generals must attack at the same time for an attack to be successful. The only way for generals to communicate is by sending a message across valley between them, but messenger might be intercepted or lost. Problem arises when generals try to reach a consensus. Synchronized attack is only chance to win. Lack of common knowledge cause an inconsistent state. Since the requirement is to attack the castle at the same time, and one army is not enough to capture the castle, generals need to communicate and decide when to attack. Lack of common knowledge causes an inconsistent state. To illustrate the situation, General B might start by sending the message, let's attack dawn at 10 on June 1st. After sending this message, General B cannot be sure whether the message has reached the target or whether it's been captured because of its uncertainty. General B hesitates to attack. As solution, we can think of General A sending a confirmation to General B saying, I have received your message to attack at 10 on June 1st. However, this messenger may also be in danger of being captured. General A hesitates to attack this time. Knowing that General B may not attack if messenger is captured, again, we can think of the solution for General B telling General A, I have received your confirmation to attack. However, again, this messenger may be captured. Two general problem. Let's attack. Received. Receive communication. Receive confirmation. Well. So at this point, we begin to understand that there is no guarantee that two generals will agree on plan of attack, no matter how many rounds of confirmation are made. Let's examine some possible scenarios. If messenger sent by General B is captured at first attempt, General A will not get any message, and General B will not get any confirmation. So there will be no consensus to attack. The messenger sent by General B reached General A. General A sent a confirmation to General B, but messenger is captured. Then General B will think the message is not received by General A, and there will be no consensus to attack together. Messenger sent by General B reached to General A. General A sent confirmation received by General B. In this case, General B will still think that General A can hesitate to attack because he cannot be sure if his confirmation is reached to General B. Therefore, confirmation is necessary, and there will be no consensus to attack together. As can be seen, each scenario leads to an inconsistency without a consensus due to unreliability of communication path. Comparison with TCP. TCP used three-way handshake, to establish reliable connection using sync, acknowledge and acknowledge. But this is only to understand if both sides can send a message to each other without checking the content of message. Then, when sending an information from one entity to another, TCP provides duplicate cumulative acknowledgement and timeout-based retransmissions to be able to ensure the message is transformed to the other side. That implies that TCP allows retries, which is not the case in two generals problem, in which we need to consensus between the entities on a subject without retries. In two general problem, each time message is exchanged, there is a chance it could be lost. As more messages are exchanged, the likelihood increases that at some point message will be lost, breaking the sequence. In TCP, ultimate target is sending an information to another entity reliably. If we would check the content and try to come up with a consensus with confirmation, but without retry, we will end up with the same inconsistency problem to the general problem. Therefore, although TCP is a very reliable protocol, it doesn't solve the two general problem because any remote communication is not 100% reliable. Network is not reliable. Two generals problem mitigation. If we accept uncertainty of this communication channel, we can try to mitigate it to some extent that we would think be sufficient. Sending many messengers using serial number. Let's say General B sends 100 messenger, assigning serial number 1 from 100 to each. As long as at least one messenger passed through General A will get the message, and also determine the reliability of channel by looking at missing number in sequence, and adapt the number of confirmation message. Everything TCP again. In TCP actual similarity there is a sequence number to capture any missing message and resend them based on duplicate acknowledgement received. Just one note, Kafka exactly once delivered also use similar approach with a sequence number, but instead of keeping sequence number in memory as in TCP, it persists that to Kafka, so that even after restart it will keep enforcing exactly one delivery. Okay, bu əslində çox uzundur. Mənim də boğazım ağrır artıq və fokus ola bilmirəm. Bu şəkildə də davam etmək istəmirəm. Bugün gəlin yayını tamamlayaq uşaqlar. Sabah yenidən davam edərik qaldığımız yerdən. Belə. Sağ olun hamınız. Yaxşı ki gəldiniz. Maraqlı yayın oldu. Sonra qaldığımız yerdən sabah davam edəcəyik. Görüşəndək, hələlik. Özünüzə yaxşı baxın. Sağ olun.